Thank you everyone for joining us for this webinar, an introduction to digital audio in the install world with Peter Moses. My name is Mallory Misnarsic, and I'm the project manager here at HARMAN. Just a few things before we get started. Everyone on the call is muted to keep down noise levels during this webinar. However, there is a Q&A function where you can submit questions to the presenter, and he'll try to answer as many as possible at the end. This webinar will also be recorded, and a link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control. We encourage you to take a look at the different webinars in our Learning Sessions workshop series on pro.harman.com, as well as visiting HARMAN Professional Training to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to the presenter for today's webinar. Peter is a 20-year veteran of the audio industry with experience in large-scale projects for universities, studios, house of worship, and mass transit systems, as well as a multi-platinum engineering credit with clients such as will.i.am. And now I'll pass it over to you, Peter.
Thank you so much. It's a great intro, Mallory. And before we let you go, you've gone. I just wanted to say thank you for organising this along with your team, and I hope you're doing well.
Perfect. Thank you.
All right. Awesome. Thank you. So everyone, thank you so much for joining me today in what I feel is going to be one of my most exciting presentations. This is an introduction into digital audio in the install world. It is not a masterpiece on the topic. It is not a thorough presentation that's going to end up with you resulting in a PhD or a doctorate in the topic. It is more about giving you a bit of an insight into it. This presentation has been put together for a few reasons. One, I thought it was really important, having spent a lot of time in the industry, that a lot of our customers, our partners being integrators, and indeed people that work for us and for other companies don't have a good understanding of the basics of digital audio for install. And that's what today's webinar is. Ideally, it'll go for more than 30 minutes, hopefully, but I do get very excited about these things and talk a lot. This is, as mentioned, designed for someone looking to get into the basics of digital audio. This is definitely a pre-AVIXA, so to speak, course. It is a pre-Ordinate certification course. It is definitely something that is, hey, you may be in the world of install audio by way of IT or by way of being an audio engineer, a live sound engineer, maybe a video engineer, or even a user, and wanting to learn a bit more about the basics of digital audio for the install world. That is what today's webinar is about. Don't fret if you've come here by mistake and we're hoping for more of a deep dive, understanding about digital audio protocols, TDM, SAP, a whole bunch of really cool stuff, really detailed stuff. I'm hoping that HARMAN will put together a number of webinars by myself and a number of my more qualified colleagues to go into that. But today we're basically just looking at an intro to digital audio. So if you've come across this live or indeed come across this on YouTube or another medium in the future, and you're wanting to learn a little bit about digital audio, this is definitely the place for you in terms of digital audio for install audio. AV all-rounders. It is surprising the amount of contractors and people on the tools in the industry running cable, terminating connections, and even doing some basic tuning of rooms, not having a basic understanding of digital audio in the install world. And again, this webinar is for people such as yourself. As we go into today's webinar, we're going to look at some basics. So a good webinar always starts with understanding what we're going to cover in the next little while. And we're going to cover the basics of audio, giving you a good understanding of what audio is so we can have a good appreciation of what digital audio is in the install world. Networks, very important. Audio in digital audio does really not exist without network control of some form. And so we're going to look at that from just a digital audio point of view. What kind of files can we push through a network? What kind of audio protocols can we push through a network? And indeed, what are some of the pitfalls around that? We're going to look at that today. Audio files and formats. We go through to some high definition audio files and formats, almost gigabytes of storage per second for audio files. I know it sounds almost impossible, but there are a few file formats out there that have that, all the way back down to 1 or 2 megabytes per second for audio files. A very big difference in size and storage capability, and also network transmission needs. So we're going to look at all that today and understand how that plays into the wider install space. We're going to look at the transport protocols. Once you've actually got an audio file, what do you do with it? Do you just sit on it? Do you want to hear it? Do you want to get it to a speaker, such as the great JBL speakers I've got behind me? Of course you do. And there's a way to do that. And we're going to look at how that occurs and the transport protocols that allow us to send and receive, encode, decode, push and pull the audio through networks. Audio files for high fidelity, really, really important. In contemporary times, we're all doing a lot of this, right? We're doing a lot of web calls, we're doing a lot of video conferencing, and we're not really getting a grasp of just how powerful audio transport protocols and high fidelity audio files are. Good audio content, just like good video content, is the difference between, you know, a really successful, stress-free video call and a very uptight and hard to hear video call. So very, very important. We then look at some of the devices that allow us to capture, encode, transmit, and receive audio. Of course, digital audio in the world of microphones, signal processors, amplifiers, and speakers. There is a lot of that at the moment. So we're going to look at some of that. Of course, it would be remiss of me to make this just about audio, but that's what I'm doing because, as you can see, I'm an audio dude. We're also going to cover how we play on the network as good network citizens, along with other types of data, control data, vision data, and generic data. You know, it's very important. People need to get their emails. They're going to be very, very unhappy if they've got great sounding audio, but, you know, a 10-minute delay in receiving emails. We're going to look at digital audio cable and indeed data cable. So important, physically getting data to and from different places. And throughout this webinar, because it is a basic introduction, we're going to look at further learning. At every stop along this path, I'm going to point you towards other webinars and other external resources that will help you develop more of an understanding and a better grounding, allowing you to go from beginner to expert in this field with obviously some practical experience. Fear not if you have any questions as we go throughout this webinar. At the end of this live session, we've got a number of Q&A options, which Mallory mentioned earlier. And if you're watching this after the fact, please type your questions in the comment section below. I will be reviewing this page regularly and open to following up with a number of questions and comments. I think that's the only way this learning session is going to become a valuable tool as we move on, by being able to continue that conversation. So enough from me. I think I've bought myself at least 5 minutes at the start of the webinar with that detailed intro. Let's get into it. So as you may already know, or as you may have seen on another webinar, audio is basically sound, and sound is a vibration that results in air particles moving closer together in compression and further apart in rarefaction. A microphone captures this movement of air and creates an electronic current. Once we've got an electronic current, we can push and pull that in the electronic world, in the analog world. And we use components to my right, such as resistors, capacitors, transistors, operational amplifiers, to make up a number of different circuits. You may be aware of some of these circuits. They're known as equalizers, compressors, microphones. Let's face it, anytime you come into contact with audio, there's a number of these circuits made up of components that allow us to capture sound and turn it into audio. From there, we can also record it or turn it into digital data, digital audio. Once we do that, we have to reverse engineer it. We can't hear audio, and we actually can't hear digital audio. What we can hear is sound. So we need to turn that digital audio, that 10000111110 file, or that electronic audio, back into sound. And we do that using a transducer, a speaker. So we're going to talk about these devices as we move forward, but that's a basic understanding of how sound is created and in turn how our ears interpret sound. Now that we understand this, the signal flow in the world of digital audio for install is pretty cool. You've got a microphone, and the microphone turns sound into electronic flow. And these days, that microphone can then turn sound into digital audio, and that is amazing. When I started this gig 22 years ago, digital audio was very different to what it was today, understandably. It was very rare to find a digital microphone in 1997 or 1998. And today, in the world of install, we find that a number of digital audio microphones are actually industry leaders in terms of being able to install a transducer on a tabletop or in a roof and have the sound turn into audio and the audio then turn into digital words, ones and zeros, zeros and ones. Indeed, it's not just capturing audio and creating a digital file for it at the microphone stage, but it's so much more. With digital microphones and arrays of microphones inside the one system, we can drive microphones, we can control them, we can set them up so they automatically follow the sound source. Really powerful things, and it's very, very exciting. The ability to simply capture audio through a microphone in our laptop or PC, all the way to capturing it digitally and enhancing it at the microphone stage, is amazing. From there, we can transmit it as category cable, data cable, and actually get it to a network switch immediately. Alternatively, we can use devices such as the BSS Blue processors, microphone preamplifiers, or indeed some of my favorite products, the bibs, which are break-in boxes, allowing us to take analog audio signal, convert it to digital, and then send it to our network. From there, we move along to the speakers, which is where we hear the audio from. Now, traditionally, we've always digital to analog converted before we hit the speakers. As we move into contemporary times, we see a number of speakers starting to hit the market that actually have the digital to analog converter internally. So we can now run the same category cable from digital processor, from network switch to the actual ceiling speaker or surface mount speaker itself, meaning that the digital audio chain gets larger. This is really unique. And what are some of the advantages around this? Well, if you are a customer or an installer, labor costs, it may be a lot cheaper to actually purchase the one data cable, the Cat6 as it is today cable, to run your infrastructure through. Alternatively, it may require you to have only one contractor as opposed to an electrician, an audio contractor, and a data contractor. Now, the exciting thing about that is that in contemporary times, we see a lot of system integrators working through these modules, bringing people on that have a lot of experience in data and indeed actually amplifying their services. Very, very exciting things. And as we move forward, no doubt HARMAN is at the cutting edge of some of this product innovation and technology. So we now have an understanding of the basic componentry around digital audio. The microphone captures sound, turns it into audio, and from there, in modern times, a number of microphones can turn that audio into digital audio at the source. Whether they do that or not, we can then push to an input box, known as a preamplifier or indeed a network switch if it's digital audio. From there, we can send the digital audio being data absolutely anywhere we want. And we're going to talk about that in the coming slides. As we move through the signal flow, we then hit the speaker. Traditionally, this has always had to be audio, compression and rarefaction, electronic current flow. These days, we're starting to see that actually become category cable, still digital audio, and we're converting digital audio back to normal electronic audio at the speaker, allowing the cones to move in and out and create sound, that vibration that results in sound. So that is the basic components around digital audio. Let's dive into the actual systems a bit more. I've gone a bit early there. So what is a network? Microphones, processors, and speakers. If they have a digital audio output or input, they are indeed sitting on some form of a network, most likely. As we look further into this presentation to audio protocols such as Dante, they may indeed have Dante chips within them. Now, this makes up a network. On top of this, any other computer device, whether it's a laptop, a desktop computer, a smart screen, a printer, a smartphone, anything that connects to your network, that connects to your switch or your routers, means that interoperability is available. Where interoperability is available, we have ourselves a network. Now, most networks do not discriminate between data. Data is data in terms of its size. Most switches have a bandwidth, a maximum amount of data they can push through. For the purposes of today's webinar, we're going to look at the 1 gig framework, the 1 gig switch. It is contemporary, what a lot of people use at the moment, but at the same time gives us a really good understanding of the potential limitations that we have around our network design. This is not a network webinar, but I will send you links in the coming presentation slides to some really cool network webinars if you have that inkling. As we move forward, as shown by Brad Grimes in his Networked Audiovisual Systems publication, a network is very similar to a freeway or a highway. A number of lanes with cars traveling on them. Those cars are data. Those lanes can be network switches themselves, or indeed the cables taking the data to the network switch. Running concurrently, parallel to the highway, may be a train line or an airport. Again, different methods of transport, but all transporting the same thing, data. Now today, we're really focusing on networked audio as data. The way to push that networked audio as data through networks comes down to not only the physical connections, but also the protocols, the rules of how to send and receive that data. A number of these protocols have very specific rules. Ordinates Dante suggests that you can go through just about any network switch or router. Other protocols such as AVB, CobraNet, and Ethernet are much more stringent and restrictive in the way they push and pull audio data. Doesn't make them better or worse, just different. We're going to investigate some of those differences in upcoming slides. As we move forward, to understand the basics of pushing data through a network, receiving data through a network, in this case audio, it's very important to familiarize ourselves with the 7 layers of OSI. The 7 layers of OSI is basically a set of rules, or if you'd like, a model that allows you to understand where your data can start or stop, being the application layer, and where it actually begins, being physical. And you can swap them around depending on whether your OSI model is something that you're receiving data through or transmitting data from. The realities are that we are receiving and transmitting data millions of times per second in just about every application we interact with. To give you an idea, a real world example of how this works, your physical layer may indeed be your Ethernet cable. So that gives you an understanding of where the data lies. These other 7 layers, which you can dive into at your own time, give you a good understanding of where certain data sits, whether it's data that is crucial to your program running, whether it's data crucial to your device interacting with other devices on a network, or indeed whether it's data that is being transmitted to you or being transmitted to someone else from you in layer 7, layer 6, layer 5. So all really important levels. No one level is more important than the other, but important to note. As we move through this presentation, we're going to talk about where audio starts and stops, where commands for sending audio start and stop. And we're going to reference the various layers within the 7 layers of OSI. We've spoken about what a network is. Each network and each device on this network at some level will interact with other devices through the 7 layers of OSI. The rules allowing these devices to interact with other devices can be set at different layers. They can be set at the network with a managed switch, or indeed they can be set at devices within preferences, within system settings. Why is this so important? If we look at the basic function of sending digital audio from one device to another, what if it doesn't get there? Sometimes we may troubleshoot and investigate the switch. Other times we may troubleshoot and investigate the sending device or the receiving device. Being able to understand the 7 layers of OSI and how the devices interact with each other via a router, via a switch, is very, very important, because that will guide us into what stage we can troubleshoot and understand where our audio, our digital audio, our data is getting stuck. Really, really important. As we move forward, we find some of the world's most popular switches include those made by manufacturers such as Netgear, Cisco. For a dear friend of mine, a colleague of mine in the United States, I know he's a big fan of HP with a wink, and other network switch manufacturers. Now, it's important to know that regardless of your network switch manufacturer, there are a number of key preferences, of key protocols that need to be adhered to, that need to be set up. So a lot of times purchasing an unmanaged switch, a switch that simply allows you to plug and play, is not ideal for network audio of any kind of scale. What is ideal is to be looking at switches such as these Netgear switches, which have a bit of thought for audio-visual transport. Now, again, it's most likely that you're going to have to get into that switch and do a fair bit of configuration, depending on how you want your network to work. But a networked switch that is managed, i.e., gives you the ability to go in and manipulate the way it operates, is vital. Of course, many of us know network switches as the things in the rack, usually connected to a lot of messy cables. And that's another really important point. When we look at an introduction to digital audio, as we do today, contractors and users and customers will know that a messy rack leads to a lot of money being spent over the life of the product. Not being able to physically and quickly track cable runs is a massive hassle. In fact, it's a right royal pain. And a lot of times a bit of effort put in at the install stage or at the maintenance stage to ensure that we have clear cabling is very, very important. In fact, there are many of us in the industry, myself being one, that find this almost refreshing to look at really well-managed cables within rack systems. And if you were to Google some hashtags around this, I think you'd find a number of really awesome and really scary examples. So pretty cool stuff. As we move forward, the network switches themselves connect to other switches, which connect to others and others and others and others. The way they connect is very important. Our friends at beginnersbook.com have put together a number of really cool basic diagrams that show you the different types of network configurations, being ring, drop, mesh, hybrid, star, a whole bunch of different ones. It's vital if you are getting into this field to learn a bit more about it. There are a number of great resources where you can go out and learn about how these types of network topologies either benefit audiovisual systems or indeed hamper them. As a small side note, it's my preference to always use network design topologies that allow for redundancy, that allow for the ability of, if one server, if one switch, if one router goes down, stops working, that I have the ability to switch over to others that will continue the traffic flow. Routing all your data through one street, through one router, can be very problematic when we look at failure. So that's something to keep in mind. Before we move on to the next stage of this webinar, let's just recap over what we've gone through. At this point, if you're new to the audio, digital audio in the install world, you are looking at what is audio. Well, audio is simply an electric representation of air moving back and forth. From that, digital audio is a digital representation of that electronic voltage, that electronic current. How does audio become digital? Very simple. It becomes digital through digital converters, analog to digital converters. And we're going to look at them in the next stage a bit more. What is a network? A network in its very basic form are two or more computers connected together. In the 21st century, in the world of AV for install audio, we see computers and networks as devices that connect together and communicate with each other, observing the 7 layers of OSI rules around how do we communicate, how do we send data, how do we pull data, push and pull, encode and decode, send and receive, very important. Moving forward, a network switch allows us to plug many different devices together and have that communal highway where we can share information. Types of networks and switches and what to know about them. Ideally, we want to know that no matter what kind of network topology we are using, it allows for some form of redundancy. If one router, if one switch goes down, we are able to change the way our lanes work and feed them to another set of devices that have the same data, the same information, allowing for, where possible, seamless operation of our audio and video. Where to learn more? At this stage, these are very broad topics that we've covered. You can learn more from each industry's governing bodies. A number of academic universities have great resources online that are available free of charge. And of course, it would be remiss of me to talk about the wonderful content at the HARMAN Training Centre, which again is free to access and online. Very cool information geared not only towards audio, but also video control and data in general around AV practices. So as we move through stage 1, we hit stage 2, which is the process. Understanding a little bit of the bland information we spoke about earlier, how do we then put that together and make a system that allows us to capture audio from a microphone, transmit it through a video conferencing program, and then hear it through a speaker? Well, the process is really exciting, my favorite part of the journey. And again, you'll find me wherever possible looking at this from a physical point of view on installs or a maintenance point of view, checking how systems are going, making sure that audio is flowing through switches and routers and there is enough highway space, enough bandwidth. Now, file sizes are vital to the process. If we're talking about a 1 gig switch, we can't push more than that through it. If we do, we get nothing, right? The switches, for those of you that are on this webinar that have some experience with this, the switches basically stop working. They get flooded, they jam up, they become inconsistent, or more likely, they just stop working. You then get a rush of people saying, hey, what's happened to my emails? Or if you have your dedicated AV system, you have no devices that you can communicate with. All of a sudden, your audio stops working. Things stop being transmitted. Things stop being received. A hard reboot of the switch is usually required. And if the same problem occurs again, then you've got another hard reboot and another hard reboot and another hard reboot. To this extent, tools such as Angry IP Scanner, which tells us what's on our network, and investigative tools such as SharkWire are very, very important, because they help us understand where there are clogs in our network and how to alleviate them. If you don't have either of those tools, you generally find people at the IT rack pulling data cables out, and that's always a really interesting process. From there, we're going to look at a demonstration of networked AV system and its requirements, taking into account network routers, switches, and indeed file sizes and what can go to and from them. And of course, the components that make up these wonderful systems. I'm having a lot of fun talking about this. And as we move forward, I hope everyone on this call and on this webinar is also getting something out of it. As we look at user cases, all the devices we just spoke about on the previous page are generally used in a number of systems. Historically, I've used them somewhat in recording studios. I've used them a lot more in live sound. Concerts of large scale have a dedicated IT team that work with the audio and video team to ensure that control of the data is being made to happen almost seamlessly. You'll usually find that the audio and visual practitioners are nowhere near the stage, usually at a front of house location or side of stage. So taking into account physical challenges such as cable runs and ensuring that the cables physically stay safe are vital. In the world of install, it's very different. We're generally, but not always, looking at unified communications. Audio being transmitted to and from other users. People collaborating on a video call, or indeed people receiving information from a video call. Some of the vertical industries that we find this in, but not limited to, are corporate, education, and other industries such as being at home, residential. In modern times, we find that a lot of our communication is done via video calls. And again, taking into account everything we've spoken about, file sizes, devices, routers, switches, all plays a part in how seamless and smooth the communication, the pushing and pulling of data is. So I'm going to stop stalling and we're going to jump right into it. Audio files and formats determine how we can transport digital audio, how we can store digital audio. There is no point having a car full of gas if you can't get it on the highway. To be able to get it on the highway, we need to understand how do we navigate our side streets? How do we stop at our stop signs? How do we go at our green lights? And all this is very important. This is, to me, equates to a number of protocols, rules set in place for programs such as Zoom, Teams, and other audio programs to send and receive audio. Digitizing the audio is one step. Transporting it is a totally different step. To that extent, we use protocols such as Dante and HARMAN's BlueLink, a set of rules that allow us to have data enter and exit freeways at different times. Ensuring data makes it through these freeways with minimal latency, minimal delays is vital. It is so important. Audio cannot be held to time restrictions. It cannot sit a second or 5 seconds back from when it was created. If so, we get a loss of synchronization. My mouth will start moving, but you will not hear me until 3 or 4 seconds later. Early in the piece, audio conversion and transport was done using methodologies such as time division multiplexing. This aimed to get audio reconciled within an acceptable time, usually about 20 milliseconds in terms of what your ear is going to perceive. However, there are a lot of examples of coming down to 9, 8, 7 milliseconds and still being able to perceive it. As we move forward, time division multiplexing became redundant and we started using more advanced, more mature digital audio protocols. Audio protocols and standards, rules, such as the Audio Engineer Society 67 protocol. From that, we have today commercial protocols such as Dante, made by Australian company Audinate. Audinate is an IT transport company and indeed an audio encoding or audio protocol company as they started out, have a product that allows you to not only send and receive multiple instances of digital audio, but also manage them, allow you to copy them one source to many, a process in IT known as multicasting. In addition to that, Audinate's protocol gives users a graphic interface that allows us to determine not only how we interact with digital audio on the network, but how users interact. Other products such as Dante Domain Manager mean that IT admins can set rules. Group A can access the audio but not manipulate it, whereas Group B can access and manipulate it. Really exciting things and things that I'd encourage you to learn a bit more about as we go through this journey of digital audio in the install world. Popular digital audio protocols are not limited to Dante. In fact, there are a number of digital audio protocols in the world. Protocols such as CobraNet and AVB have been around for a number of years and are coming to the maturity stage of their life cycle. Having said that, I have seen both protocols in a number of installs globally that are bulletproof. So just because a protocol is dated or may not be the most current way of doing things, if the protocol works, there is a lot to be said for holding on to it. And we see that with many of our large enterprise users. HARMAN themselves have come up with a wonderful digital audio protocol known as BlueLink. BlueLink, for me, is one of the fastest digital audio protocols on the market today. And as we move forward through this presentation, we'll see what that really means. Audio-visual data needs to follow a set of rules. Those rules can be very limiting or very powerful. A common set of rules or a protocol that many manufacturers and end users adhere to these days is the Audio-Visual over Internet Protocol, AVOverIP. The benefits of AVOverIP are vast. Some of them include being able to take different data, encode or decode it, and put it through a switch. This is so very important. Being able to put that data through a switch means theoretically, with the right permissions, we can transmit that data over the internet to end users, to major broadcasts, or even to a node on the other side of the world that is recording that data. So very important. Think about global communications. Think about live concerts that we see, or even streaming YouTube audio through YouTube Music, all being done using AVOverIP. Another protocol slightly different is the HDBaset standard. Made by the HDBaset Alliance, this subscribes to a slightly different methodology of pushing and pulling data. It is not as easy as putting it through a switch or router. In fact, sometimes that's the last thing you do with it. However, it does allow you very fast and strong communication from one point to another when connecting two devices together. We see HDBaset being used in the professional audio industries every day, but we also see HDBaset based on its ability to connect two devices together used in the consumer world as well. Both protocols have a lot of advantages and disadvantages to them. One is not better than the other, but again, making a choice around which protocol you want to use, which standard you want to use, comes down to the ability of being able to sit down and plot this information out before building a network, something that we really recommend just about every architect or user does. Let's move forward from the actual transmission of audio and see, how does audio become digital audio? Well, it's done in two phases, more than two really, but we're going to break it up into two simplified phases. The sample rate is achieved, which is basically a number of pitches taken every second. In the world of CDs, we take 44,100 pitches every second, looking at how the sound changes over time. Once we know how the sound changes over time, there's also another way of measuring it, which is how soft or loud it is, known as its dynamic range. Dynamic range is measured in bit depth and usually decibels. Now, there are a number of different ways to measure decibels. For digital audio, we generally use dBFS, among others. When we look at measuring the biggest difference between the softest sound to the loudest sound, we're looking at decibels. We're looking at bit depth. 16 bits, which is the bit depth of a compact disc, a physical medium, allows us 96 decibels of variation between softest, quietest to loudest. These days, a lot of digital audio protocols support higher resolutions that go as far as 24 bits, which give us 144 decibels, outperforming the physical CD medium. When we look at this, Of course, it's vital to know that 16-bit files versus 24-bit files are going to have different file sizes. Again, bringing it back to digital audio, bringing it back to the network, bringing it back to the router. The bigger the file size, the less amount of files I can fit on my network. And this is very important. This perhaps today is our first golden rule of thumb. As we move forward, it is not just the audio file and the size of the audio file, the resolution of the audio file that we care about, not for a recording point of view only, not for a transport point of view only, but a processing point of view. Encapsulating audio as a digital file gives us many advantages. Some of those advantages include being able to record or transmit the audio, but more likely being able to manipulate the audio, being able to change the audio, removing sounds from it, making a man sound like a female, making a female sound like a man, or more practically, in the world of unified communications, removing echoes. And to do all that, we need to push and pull audio to different physical devices or indeed different computers sometimes on our network. To do that, we have to take into account again our file sizes. If I have 100 digital audio files being generated, how many of them, how big are they, and how many of them can I push through my router every second? If a digital audio file was 100 megabytes, I could push 10 of them per second through my network. However, that would be maximizing my network at 100%. And that is a wonderful topic on its own. We don't generally max out our networks. So I like to subscribe to the theory of 75 to 80% maximum bandwidth, allowing 20% not only for other network traffic that I'm probably not calculating, but more so allowing for a bit of headroom. So very, very important. When we put our routers and switches in big drive racks, in those big server rooms, we sometimes don't account for heat, for air ventilation. And as devices get hotter, they operate differently. Now let's look at that in practical terms. If I have a digital audio source, there are up to 6 different places I can interact with it on HARMAN's BSS Blue 806DA. If the audio adheres to the Dante protocol, I can send it to my processor via the primary port. What's important about this is that I can transmit and receive audio via this one connection. This allows me to use the BSS 806DA to manipulate audio, to remove echoes, to limit volume on microphones, and indeed do a number, of wonderful performances, such as muting audio, such as taking audio from here and sending it there, and everywhere else, routing, assignments, and indeed even outputs to record can all be managed via the Blue 806DA and its accompanying Architect software. Now, what makes Dante one of the most popular digital audio protocols in the world is that if the primary port all of a sudden goes down, we can have a secondary port available. Configuring your network and your devices to transmit primary and secondary Dante information is a very, very good practice to get into the habit of doing, especially for enterprise systems. It means separate architecture and separate hardware. But again, when we're looking at mission critical meetings, when we're looking at things such as live concerts or broadcasts, it's vital to have that differentiation. We go so diligently through these different paths that they even have different sources of power. Really important and exciting stuff. Moving forward, it's not just the primary and secondary Dante ports. It's also, in this case of the 806, HARMAN's BlueLink port. HARMAN's BlueLink port does not allow you to push and pull information through a switch or a router. Indeed, it is designed to be a circular network topology, going from a blue link in to a blue link out of another device. The beauty of HARMAN's blue link protocol is that you'll find it's one of the fastest and widest in terms of bandwidth audio protocols on the market. A very exciting and advanced protocol found traditionally in most HARMAN equipment. The difference between BlueLink and Dante, there's a number of differences. Dante is more an industry protocol that is used by many different manufacturers, competitors of HARMAN, as well as HARMAN. In addition to that, another port that may be able to transmit and receive information, but not necessarily audio, is the Ethernet port. The Ethernet port allows us to connect the processors on board of the 806 to a network switch. From there, we can use our software known as Architect or a range of other software programs to interact with the devices internal to the 806. Finally, digital audio just does not live on category cable. In fact, for a number of years, it lived on various different coaxial cable. And that is still a part of the Blue 806DA series and a number of other products on the market. The connections are known as SPDIF connections. That's right, SPDIF connections, Sony Philips Digital Interface Format, I believe. And really important to note that that protocol itself is almost 40 years old as we move into the year 2021. So very exciting. As we start to look at a real world example being a multi-story building, we need to know that, again, the basic rule of thumb around size and file formats. We know that there are protocols such as Dante and BlueLink that, there are also methods such as AVOverIP and HDBaset. We know that network switches and routers are vital to audio on protocols such as Dante moving back and forth. And now with this example, which again, most people on the call probably already are well familiar with, we have a basic understanding of the way we measure data, not in centimeters or millimeters, not in inches and feet, but in kilobytes, in bytes, in megabytes, in gigabytes, in terabytes, and so on and so forth. I tap out at megabytes, so biting off anything more than a gigabyte is probably way above my head. As we look at how this applies to a real world example, let's check out the huddle space. If we look at a 4-story work environment or a 4-story university or even a 4-story communal building, we see that a number of users may be using Zoom or another video call application through their mobile devices. If we have 4 users, each using an instance on their mobile devices, we're generally looking at about 2.3 megabytes per second, but that can fluctuate. That gives us so far a total of 9.2 meg roughly being used by those users on their devices on the network every second. 10 megabytes, and I've got 990 megabytes to play with. Theoretically, we're going to subscribe to the notion of playing with another 790 megabytes. We're not going to use the full bandwidth of the switch. To do that, I know that I have a heck of a lot more room to put other data through my network. I then look at using 5 different instances of Dante. Now, every Dante flow gives me up to 4 channels that I can use. And the size of one flow is approximately 6 megabytes. So if I was to use 5 flows at the moment, I'm using a fair bit of bandwidth. In fact, 6 megabytes on one flow, 5 flows, 30 megabytes. I can have 2 different Dante flows. In fact, most people have multiples of 10 or even hundreds of Dante flows, depending on what they're doing. Now, to give you a practical example, a Dante flow consisting of 4 channels may be a microphone. That microphone is then assigned to a noise suppression device, 2. That microphone signal then comes back from the noise suppression device. 3. That microphone signal is then transmitted to the next receiver in the chain. 4. You can now see just how easy it is to get these counts up very, very quickly. If I'm using my Zoom model, my Dante A and my Dante B, I'm sitting at about 46 megabytes. Let's call it 50 megabytes, as we always like to round up. If we're rounding up to 50 megabytes, I still have 750 megabytes at best to play with. Let's now look at transmitting some high definition video. The second we bring video into the conversation, all bets are off. Uncompressed high definition video can be in the gigabyte range per second. Now, if my network can only support 800 megabytes bandwidth per second, 1 gigabyte, let alone 4, 6, 8, 10, 12, 20 per second is well out of the question. Simply dumping one digital video file on the network that is uncompressed could wreak havoc. So to make sure that we're good AV citizens on the IT side of things, what do we actually do? Do we crash the whole system? Probably not. And again, a lot of times, digital audio practitioners will get a call saying, I have an audio problem, the audio is down. The reality is it may be another citizen on the network. It may be another data format on the network, digital, video, or otherwise, that is taking up the majority of that network. So while the result is that the audio is down, the actual problem could be nothing to do with the audio flow. However, taking some form of responsibility and investigating is always a good idea. How do we actually put data that is large, such as digital video, on and off the network and have it run side by side with audio and other data? Very simple, we compress it. Now, while today is an introduction to digital audio, HARMAN's brands, including AMX and SVSI, make some of the world's most popular digital video compression tools. I encourage you to have a look at them because even as a digital audio practitioner, a basic understanding of these solutions is vital to understanding how to put together a healthy digital audio network. The cool thing about these products in contemporary times is they are a complete AV ecosystem. A number of the SVSI encoders and decoders offer you the opportunity to encode, decode, and transport audio as well. In addition to that, you can create a control backend that allows you to have complete touchless interaction with these devices. You're no longer relying on just one communal touchscreen. You can actually scan QR codes in some instances and use your own personal device to interact with them. It's a wonderful part of the AV industry. It's a growing part of the AV industry. And it's something that if you're on this webinar, I think you'd get a lot of benefit from investigating it further. Back to the example though. As we put forth our SVSI digital encoder and decoder into our system, we now see that we can compress what was perhaps a 2 gigabyte file, a 3 gigabyte file, down to 600, 800 megabytes. When we're looking at those type of changes, to compress and not necessarily receive, but just send, 600 megabytes for me works. 600 megabytes per second with another 50 meg of audio gives me 650 megabytes per second for my AV. You can sprinkle on top of that some control data. You can, of course, sprinkle on top of that some data that is not necessarily AV, and you're still well under your 800 limit for a 1 gig router or switch. This is important. This is vital. If there is one thing you're going to take away from today's webinar, it's understanding bandwidth and how our network is limited by the amount of bandwidth available to us. So as we wrap up the real world example, we look at how does this apply? Well, if we have a happy network that has traffic on it well under the bandwidth, we're getting crystal clear vision. We're getting crystal clear audio. And more importantly, we're getting uninterrupted ability to communicate with contemporaries, be them colleagues, be them customers, be them faculty, students, family, friends. When we have a network that can support our data and still have some headroom, we have a network that is able to perform to the specifications of the hardware on it and also the software. And that is a really wonderful thing. To learn more about network design, I would encourage you to follow this with a wonderful webinar by a colleague of mine, Kyle Barron, on effective top-down network approaches. It's a wonderful beginners type of webinar. You don't need to know too much, but gives you a really good example into one of, I believe, the AV industry's smartest minds around some of the elements around effective network design. Moving forward, we now know some of the devices and how they live on a happy network, but what would we use them for? Well, in contemporary times, echo cancellation is massive. My history would always see me actually dealing with echo cancellation historically in a recording studio that was very live, that was very big. And I would have vocalists sing and producers or record label people say, hey, there's too much echo. Can we use echo cancellation? And that's not what it's for. That's not what it was designed for. And I almost always would say yes and then do nothing about it. Now, in the world of install audio, it's a very different case. We want to use echo cancellation. A lot of times we'll be making calls from rooms and spaces that are not designed for good audio. Because of that, we get echo, we get slap, we get all sorts of nonsense that can be really disturbing when trying to get a form of communication across. To that extent, HARMAN and a number of other wonderful digital signal processors, digital signal process manufacturers put together echo cancellation software, algorithms, presets that you can use to remove echoes. Now, you can do this within a number of your current video call software packages as soft codec methodology, or indeed you can get it out on the Dante highway, on your digital audio protocol of choice highway, and get it to a dedicated echo cancelling processor, such as a number of ones made by HARMAN and DBX, along with BSS, or industry standards that are made by competitors. The ability to use an echo canceller means that we remove the distracting echoes that come along the audio line. It's an art form within itself, and perhaps that is a webinar within itself, because setting them up requires a lot of information, both from a network point of view, but also from an audio practitioner's point of view and a scalability point of view. But I think I've just given myself or one of my colleagues a wonderful idea. As we move forward, what else would we use on our digital audio network? Well, we've said it time and time again. You know, your network is only as good as your switches if you are running AV over IP. To that extent, there are a number of wonderful switches made by a number of manufacturers, including Netgear, Hewlett-Packard, Cisco, and others that are in some cases designed specifically for very high data bandwidth. They may not be the corporate giant names that you're used to hearing, but nevertheless, very, very reliable ones. In addition to that, some of the devices we use on our networks to manipulate the audio include the DBX AFS2, a wonderful feedback suppressor. Think about all those horrible times you hear the things that we really don't need in 2021 and beyond. Utilizing the DSP library of DBX's AFS2, we can remove them to some extent. In addition to that, we can combine that with a HARMAN BSS Blue 806DA, which allows us to not only control different frequencies through parametric EQ, but route, assign, manipulate, and of course, in some instances, echo cancel. So very cool. As we move forward, it'd be remiss of me to say more and more we see HARMAN and competitors coming together with these solutions on one physical device. So if we look at a device such as the new generation AMX DVX, we can see that it has a number of options for us. Using DX-Link, we can actually transmit, send, and receive, pull different data. Data that may not just be one specific variety, but a number of them. Of course, using HDMI, we can transmit and in some cases receive vision, audio, and of course the data that sits around that HDMI. In addition to that, the DVX has a number of analog microphone inputs, meaning you got it right, that there is indeed analog to digital converters on board of the DVX. And one of the wonderful things about this product, not making it an infomercial, is that being a HARMAN product, we are not using generic analog to digital converter circuitry. We are not using standard plug and play things. We are leaning on decades, if not 70 years of innovation, understanding of electronics and how they apply to audio, and putting that into this circuitry. In addition to that, the DVX has amplified outputs. It actually has an amplifier on board, meaning, again, you got it, it's got a digital to analog converter on board. If you want to go or stay within the DVX in a digital format, you can do that using the Dante protocol. So again, it is so exciting to look at how in the 21st century, in 2021 and beyond, in contemporary times, we're able to take video transport, audio encoding, audio transport, and audio decoding, along with control, and put it all in the one hardware box. And I think that is so exciting. It'd be remiss of me to say that a number of our competitors also do similar options, but in my biased opinion, this is definitely one of the most exciting options as we enter 2021. Moving forward, I'm going the wrong way on my slide, so let's go forward, not backwards. It's not just the hardware, but it's understanding more about some of the topics we touched on today. To that extent, I'd reference you to one of, if not both, digital audio webinars by a dear friend and colleague of mine, Al Crane from HARMAN. Al's webinar on digital audio conversion really drills down the art of ADC and DAC and looks at what are the different factors that apply to a basic converter to a very advanced converter. Al's second webinar is Audio over IP Protocol, talking in detail about some of the protocols we've touched on in this webinar. Of course, we've just mentioned them because today is an introduction, but Al's Audio over IP Protocol is one of my favorite webinars on the topic as a whole. It'd be remiss of me to not also mention some other work in the audio webinar field that adds to some of the wonderful conversation around it. Patrick Kalani, who is one of Audinate's senior technical trainers, has a wonderful saying, which is data flows through a switch, not to it. And when we revisit our bandwidth limitations and the requirements for them, it's to understand that we don't want to clog the switch or router up, because that is not the final destination of the data. The switch and the router are merely highways. They are lanes. They are allowing the flow of data to go through them, not stop at them. Very, very important. Having said that, as we begin to wrap the webinar up, it's also vital to mention, and perhaps on another time go into it in detail, unicast versus multicast. Both these modes are ways we can configure network ports on a network device. A unicast stream allows us to send one piece of audio data that is digital from one device to another via the ports on our network. If, however, we have the support for multicast flow, we can send that one piece of data, but then send it to multiple devices at the same time. Of course, one of the problems with this is that unicast is a 10 megabyte file remains a 10 megabyte file. But with multicast, 3 instances of a 10 megabyte file give us 30 extra megabytes per second that our network has to deal with. This does not mean that multicast is not ideal, but both unicast and multicast are vital to the transmission of good digital audio on more advanced and stringent, or what I like to call rock solid networks. To that extent, I definitely suggest you look into unicast and multicast a bit further if you wanted to learn a bit more about network configuration for digital audio, and indeed some of the wonderful sessions on the HARMAN Learning Center will steer you in that direction. What's important to know is that as we spoke about our routers and switches earlier, being able to deal with a managed router allows me to determine how that router works with multicast information. That is something that is not offered to me on an unmanaged router. Indeed, as we move forward and towards the end of this webinar, it's vital to know that one of these sections is not going to give you a healthy network or a rock solid network. It is all these sections combined together. It is your digital audio file sizes. It is your digital audio protocols, how those files integrate with other devices on the network and how they behave on the network themselves. It is ensuring that your network has enough headroom, enough free space to never be put in jeopardy, to never clog up or jam. And it's important, of course, to know a bit more about the other types of data outside of digital audio that may live on your network. Indeed, as we look at some specifications around video, you can see that they really outnumber the amount of size you need for audio. So knowing a bit more about digital video, if it lives on the same network as your digital audio, is very, very important. Of course, the devices that send and receive and manipulate digital audio are vast. If we look at the Dante protocol allows for certain devices manufactured by HARMAN and other manufacturers to transmit Dante from microphones, through routers and switches, not to them, through processors such as the BSS DSPs, the Blue 806DAs, and indeed, in some cases, to speakers that have Dante chipsets in them. Very, very exciting to see what was traditionally an electronic flow now become a digital flow. To learn more about the various subplots of digital audio, I would recommend you look at my colleague Jeff's wonderful webinar on the actual physical element. Cat5s, RJ45 connectors, and making those connections. Of course, the physical durability of a connector is so vital to our network. In addition to that, it's also looking at how AMX, how SVSI, how BSS, how HARMAN, AV gear, and routers and switches made by companies such as Netgear work together. To that extent, my colleague Kyle Barron has put together a wonderful webinar with some of his friends from Netgear who allow us to look at how these two devices communicate and play happily together on the network. Finally, we can't talk about digital audio without talking about the physical connections. If you were to ever see an example such as the one with a lot of messy cables, I would challenge you to open a conversation around how over time it can look more like a network switch that is clean. Although it's physical, and although we often say, it's never going to get unplugged, no one's ever going to go behind there, it is so important to understand that dust buildup, good airflow, and again, easily identifiable cables are all implemented within networks. So often we look at digital audio and its ability to traverse networks based on looking at a screen, setting up switches and routers, writing some code, and building digital signal processor modules. Let's not forget that it is also the physical medium that helps us ensure that our networks are rock solid. I'm guessing I've gone just about over time, so I'm going to jump through the next few slides, which talk to us a little bit about digital audio protocols. Audinate's Dante protocol, as mentioned, is one of the leading industry standards. Used by many manufacturers, including HARMAN, Audinate's Dante allows us to transmit and receive digital audio as data through networks. Using the Dante controller application, we can set up a number of rules as to how those devices transmit and receive audio. Moving further along, we can use other programs such as Audinate's Digital Domain Manager, which allow us to actually go in and set different rules for different users. Other protocols of note would be HARMAN's BlueLink. Now, again, that is a point-to-point digital protocol as opposed to one that will flow through network switches. But the unique thing about BlueLink is it is super fast and, again, very, very wide. So it can send a lot of different audio streams concurrently. In addition to that, Ravina, a popular European protocol, really stands out from the pack when it comes to sample rate and bit depth, allowing users to get a bit more resolution than some of the other protocols on the market. AVB historically has been a protocol that many users use, as has CobraNet. But again, as we spoke about earlier in the webinar, both these protocols are seeing the later stages of their product cycle, not the end. As we recap this webinar, it's important to note that the topics we touched on today are just samples. They're just introductions to the different elements that play a part in a rock-solid digital audio network. For more learning, for more data, and to increase the conversation around this, I would suggest you stop off at the HARMAN Professional Training Centre. All the modules on this centre are free for you to undertake and watch. In fact, you don't even need an account to watch the modules. It's a wonderful resource that I know myself and many colleagues globally are adding to on a regular basis. In addition to that, what can AV do for you? Find out at AVIXA. AVIXA is one of the industry's leading governing bodies and also can accredit you with a CTS certification. For those of you that are AVIXA members, I believe today's webinar holds one CTSRU, which is pretty cool. Finally, Audinate's Dante certified training is a wonderful resource to learn more about Dante specific protocol rules and regulations. It's a wonderful source for basic learning and can really take you on that journey from entry level all the way through to expert with level 1, 2, and 3 certifications. Having said that, I thank everyone for their time. As always, I encourage feedback, questions, and ongoing comments around this topic. And again, hope it was a wonderful introduction into the world of digital audio in the install world. Having said that, Mallory, I'll now hand back to you and thank everyone for joining and open the floor to any questions I may or may not be able to answer today.
Great, Peter. This was a great session. It doesn't look like we have any questions in our Q&A. If you guys do have any questions, we'll give it a minute or so for you to enter them in there. And Peter, do you want to let the audience know where they can reach you should they have any questions in the future?
Absolutely. Anyone on this call can obviously reach me on the YouTube page for HARMAN that this is posted on. In addition to that, my email address is peter.moses, M-O-S-E-S, @harman.com. And again, the wonderful people at HARMAN are always very happy to help our partners, our end users, and people in the IT and other disciplines continue the conversation, not only just around digital audio in install, but again, all the solutions on the IT network that we provide.
Perfect. Well, I don't see any questions. Again, Peter, thank you so much for your time. This was a great session. And everyone who attended, thank you. I hope you guys all have a great rest of your day.
Thank you so much, Mallory. Take care.
Bye all.